Morning, everybody. Welcome and thank you all for being here. My name is Jacob Renn. I'm joined with John Daly. Really excited to have you here today as we talk about using AI to enrich experiences in the metaverse. So a quick agenda, what we're going to cover today. We're first going to frame our talk by answering the question, what makes the metaverse the metaverse? Then we'll look at some current trends in AI, machine learning, and give some examples of some of those machine learning models in action. We'll then talk about AI in the metaverse and really go into applications of using AI in the metaverse. Talk about some challenges and ethical questions for its use, and then start to answer and give some possible solutions for those. Lastly, we'll leave you with some information moving forward, and we also have a Birds of a Feather talk tomorrow. We hope to see you all there as well. A little bit about us. As I said, my name is Jacob Renn. I'm co-founder and CTO of AI Squared, and I'm also creator of the Beyond ML project, which is a Linux Foundation AI and data project that we contributed in June of this year.
And my name is John Daly. I'm Director of Solutions Architecture at AI Squared. Prior to co-founding AI Squared, my background was in spatial computing. I founded a startup in augmented reality that was granted multiple patents, particularly in regards to blockchain-based permissioned remote authoring of 3D content geospatially in AR, but also in VR as well. So what makes the metaverse the metaverse? Royal talked this morning a lot about the different concepts, technologies, definitions that encapsulate the metaverse. And there's so many definitions floating around the internet. Mark Zuckerberg talks about embodied internet presence being a major component of that. The 3D web, which is why we're all here. But then crypto and NFTs get brought in. A lot of people in the crypto space talk about NFTs being the metaverse. I was at South by Southwest earlier this year, and that was a big track, but it wasn't really 3D oriented. And then there's competing terms like spatial web, immersive web. But really the common thread that connects all of these is an enhanced and increased immersion. And that increased immersion can occur through increased context and perception. And that context and perception is multimodal and multisensory. So it's not just 3D, it's not just what you see, it's also what you hear. It's spatial audio, it's immersive narratives and stories and experiences through games and through how you interact with people and AI in that manner. And so we're going to talk about AI tools that facilitate this immersion on the next slide.
All right. So let's talk about some current trends in AI that we've seen. So about 5 years ago, the transformer architecture became released, and that's really revolutionized natural language processing. As opposed to LSTMs and other types of models, transformer architecture applies self-attention and other attention mechanisms in a purely feed-forward manner. And that's really powered some really powerful machine learning models such as GPT-3, BERT, and Daly. I'm sure everybody here is also familiar with GANs and other types of generative networks. But what those, in case you're not familiar, what those models do is essentially creates images, a lot of times, images or videos that are completely synthetic, from essentially random data. So they're really generative in nature. And how you do that is you have two typically neural networks working against one another. One is designed to take random input data and generate an image from that. And the other model is trained to discriminate or determine if an image is generated or real. But what you end up seeing is as you keep training these models and improving them, we get generated data that's virtually indistinguishable from real images. In terms of 3D rendering and 3D environments, we're also seeing neural radiance fields, or NeRFs, which allow us to basically scan in real-world objects, like that projector, for instance, and create 3D models and 3D renderings of those objects that are virtually indistinguishable within 3D environments. Another form of generative model is a diffusion model, which takes a slightly different approach to GANs. But if you're familiar with or have ever played with stable diffusion, that's a type of model that can generate realistic-looking sceneries, images, etc., from prompts, from written text. You can say, I want an image of a cat playing volleyball, and it'll generate an image, give you a few examples of different images that you could use from that. On a more theoretical side, we're also seeing the rise of what's called self-supervised learning. So traditional machine learning models are very data hungry. You need a lot of labeled training data to teach a model to perform whatever it is you're trying to teach it. With self-supervised learning, we're actually seeing methods to allow a model to train without labels, at least at the start. So what we get are very generalized models that can either identify or work on text as well as images in different ways. And then we train those very generalized models on a variety of downstream tasks with much less training data. That also leads to the last bullet that I have, which is multitask artificial neural networks, which more accurately represent kind of how the human brain works. If you're interested in that and how we're approaching that problem with Beyond ML, I'll also invite you to our talk tomorrow, Multitask Machine Learning and its applications to the metaverse.
So all of these models are powerful on their own, and there's been a Cambrian explosion of demos showcasing just how many different applications can be made from them. So for instance, in the top left, you can see a nerf to capture base reality and bring it into the virtual world with high fidelity graphics. You can also use it to create a base map to localize devices and place virtual content within the real world, which is something that a lot of the AR cloud startups and companies are working on, and even self-driving car companies are working on to create a model of reality that can then be used in simulations and placing 3D content geospatially. Models like Stable Diffusion in the middle can be used to create new high-fidelity skins and textures, reproducing, for instance, book characters from the text that actually describes them. So you can sort of approximate what the author kind of intended the character to look like and place that within a game or an experience. GANs can also be used to digitize real-world people, enabling you to change your avatar to your favorite actor or character, or they can be used to synthesize conversations that never really happened, resurrecting dead historical figures and putting them in your game as an NPC, for instance. Finally, you can imagine combining all of these tools as building blocks. They're powerful on their own, but compounded and chained together, you can create complete, cohesive synthetic realities. You can capture and create and automate the creation of 3D environments with the library of real-world 3D scans that you have. Quixel is one company that has capitalized on 3D scans through their Megascans library that you can port into Unreal Engine 5. You can automate the creation of virtual skins from real-world people. You can generate realistic 3D audio for NPCs and bots. And so you can create this profound simulated environment with this synthetic data. And there's still a lot of work to do, obviously. But we're really getting to the point where you can create robust digital twins that are literally becoming, pretty much as identical to reality as you can get. And so Jacob's going to go into some more AI use cases beyond just that.
Yeah, absolutely. So obviously using AI to generate real worlds is going to revolutionize how we think about the metaverse. But the applications don't end there. We can use AI in the metaverse in many ways that we use AI now. Content moderation, making sure that if you have an age restriction or you need appropriate content within a certain environment within the metaverse, we can automatically perform content moderation using machine learning, using AI. As well, for a lot of people, using the metaverse at first is going to be a jarring experience in terms of getting your footing, figuring out how things work. And we can't necessarily have somebody guiding you through every step of the way. So creating AI guidances, assistance, those types of things, helping you perceive the environment, helping learning how you like to set up your environment, set up your field of view, doing those types of things as well. AI can help create more personalized experiences as well as creating bots. So we talked about generating characters, generating avatars, but also making bots seem more realistic. having those conversations using purely machine learning models, and doing that kind of work as well. Obviously, we're just seeing the beginning of these types of use cases in the metaverse too. 5 years from now, all of these may be solved. There's probably going to be 100 more new problems, new opportunities for using AI within the metaverse.
So even with these new significant capabilities, facilitating enhanced immersion and enriched experiences, we need to talk about some of the side effects of that. So the first obvious side effect to enhanced immersion is the potential confusion that can come regarding what is real because of that enhanced immersion. Deepfakes are permeating the internet at an ever-increasing speed, and they're definitely becoming already problematic. Whether that be placing people's faces on nude bodies or fabricating political speeches or scenarios, deepfakes are already being very intentionally used in intentionally malicious manners, especially by state actors. But that confusion doesn't even have to come from AI. It can simply come from high-fidelity synthetic environments. Earlier this year, several news channels were either misled to show or perhaps intentionally showed high-fidelity video footage of a video game called Arma 3 that was passed off as genuine footage from the war in Ukraine. So AI synthesis has already created an atmosphere of misinformation and doubt that is a real issue with real consequences in base reality. Additionally, when you merge the internet with the real world, you bring the real world, or you bring the real world into the virtual world, you bring the problems of the internet and its scale and make it very immersive, personal, and even local. Think about the real dangers of doxing somebody in AR. You could be walking down the street and hold up your phone or look through your glasses and see information about who's living in what house, what their recent opinionated Twitter or tweets have been. And you can maybe even use an AI algorithm to run sentiment analysis on those tweets to infer what their political opinions are. And it only takes one person with a bad attitude to throw a brick through your window. Or inappropriate behavior in VR. There's already been scenarios where people have hid behind anonymity and act in a way that can make harassment even more immersive, such as groping and things of that nature, without the accountability. And so AI in the metaverse can also lead to some behavioral changes through algorithmic manipulation of content. We've already seen that in 2D social media. There's been plenty of documentaries about that through The Social Dilemma and things of that nature. And we're seeing a rise in video game addiction through the likes of Fortnite too. If many people already spend 4, 5, 8 hours a day. I've seen one of my friends spend like 10 hours a day one time just browsing Instagram, sometimes more. Imagine how long they will spend if they are immersed in a very information-rich and immersive environment all around them, whether that be in AR or VR, or even just on the computer. Finally, with the entire world becoming digitized by AI, who will own all of these digital twins? Will they become as ubiquitous and accessible as images and videos, or as GLTF and USD standards become more permeated and decoded by a lot of different applications? If I buy a physical property as a business or individual, should I own all of the digital layers of that physical property in AR or as it's captured and brought into VR? Because I would probably want to avoid some of that harassment and misinformation issues mentioned before. With more cameras and IoT devices and AI scans capturing the real world, there's obviously going to be more digital twins, but do we have to accept less digital privacy as a result of that?
So in summary, challenges and ethical questions with AI, specifically as they apply to the metaverse, kind of fall under two categories. So there's already challenges and questions about the use of AI in the 2D environment that we have now with the internet. There's been intentional misuse of AI. Twitter bots that propagate perhaps incorrect, either just because they come across it or intentionally propagate that information. Adversarial machine learning. That's another use case for machine learning in a potentially nefarious context. Building models that intentionally exploit some of the problems or the assumptions that other models make. Generating images that are classified incorrectly, either to get through content moderation filters or other use cases as well. Another problem that's kind of an unspoken issue within the machine learning community is biases that models can have. These can be propagated through simply the training data that we use to train models. So a lot of data that we get is just parsed from the internet, and that has societal biases in there, which may have been, propagated through the last 10, 20, 30 plus years, depending on what information you're using. We've done studies on some large text models, and they may incorrectly bias either people of certain races or genders with certain roles within society that don't really apply. It's a societal bias that has been historically perpetuated. But the metaverse also applies other challenges as well. One of the problems with machine learning in today's world is we have to create a way to digitize the real world today. With the metaverse, that's not going to apply. The entire world, the entire universe, if you will, is going to be digital. So there will be unprecedented uses for AI, to train AI, to use AI within that type of environment. John hit on a lot of those, but there's really going to be tons of questions about data ownership, model ownership, who's responsible for a model's actions if you allowed it to train on your data. Am I responsible for a model that I didn't train, but it was trained on data that I allowed to be trained on? Different questions like that are going to be critical kind of moving forward as we figure out what best practices to apply AI in this environment.
All right, so we talked a lot about the side effects of these new advances in AI, and as it can, and the side effects that they can bring, especially pertaining to the metaverse. In my opinion, a lot of these issues can be mitigated, and to certain extents, by robust data privacy practices. This not only includes clear data privacy rules and guidelines, but robust and significant enforcement of breaches of those guidelines and agreements. If it's still commercially viable to continue breaching regulations because the fines are cheaper than the profit, then that's an issue, and that needs to change. Control to the creators is a necessity. Giving IP rights to people so that their creations are not used in malicious models or used in deep fakes or used in ways that they don't intend is really, really vital. This can be done through broad data provenance and indexing, and perhaps there's another use case of AI to assist in that indexing and identification, so that you can track where your data is being moved across the network and what identities, either human or AI, are accessing your data and what they're doing with it. Standards groups like Adobe's Content Authenticity Initiative are doing good work to this end to combat misinformation and deepfakes, and AI Squared is a proud partner of that. And that brings me to standards. So everyone seems to throw standards around as this catch-all solution to the tech world's issues. But standards mean very little if there's little buy-in and too many standards competing with each other, especially if standards are backed by commercial entities that have an incentive to have their standard be the dominating competitor. So we need better communication across standards organizations, and perhaps even the merging of standards organizations. But at the very least, a lot more cooperation. Lastly, on that point, when it comes to digital privacy and data ownership, there's an open question of whether standards will even meet a threshold of adoption that will prevent secondary markets from emerging that kind of defeat the point. So for instance, if we set up a blockchain NFT system as a digital rights management engine, what happens if somebody acts like they're a good actor until they get permission to decrypt whatever content they have access to, and then they can do whatever they want with it, and then the data is not traceable after they, exfiltrate it from that network. Going on to models, so we need to standardize model tests as it pertains to AI. AI needs to be self-identified. We need to know when we're interacting with AI. We need to know what data is being utilized in certain models. Open sourcing models is going to become very vital so that we know, what is being fed into them and why. Trustworthy AI needs to be researched a lot more, which is something that we're working on. And model feedback to that end is going to be crucial. People providing informed feedback on the effects of a model, so that we have more subjective, feedback in terms of the effects of what it's doing to individuals is going to be crucial as well. And data provenance and tracking and indexing is going to be, again, crucial to that.
So as we start to wrap up our talk here, I want to leave you with a few thoughts moving forward. Number one, if you leave here with nothing else today, just want to instill in your minds that AI and the metaverse are going to be intertwined in perpetuity. The metaverse is not going to necessarily exist as we need it to without the use of automation, without the use of AI tools and techniques. So moving forward, open source is going to be hugely important, just as it is in just about any other technology field, in helping define industry standards. Obviously, with open source, solutions to problems become available to all. There's increased collaboration there, and then we can build on top of that. So as different companies come out with their own versions of the metaverse, open source can serve as that foundation layer where we can build on top of that, have interoperability, and all of the things that we're talking about here at this conference. On the AI side, further studying AI, machine learning models is going to be critical. So we have many issues in traditional machine learning models that we've talked about, and then also further issues that are going to arise, foreseen and unforeseen, within the metaverse as well. So solving both of those issues is going to be critical. So eliminating biases, or at least measuring and really figuring out where these biases are coming from within models, making that known, making that transparent. We're going to have to create different ways to test models, both initially as well as as they continue to train, as they continue to get better or worse. How they're interacting with that environment, providing feedback to how a model is performing. As a user, as an experiencer of the metaverse, I need to be able to tell people who are developing these models, hey, this behaved in a way that was unpredicted, behaved in a way that it perhaps shouldn't have. And just as with everything else, building best practices within AI and the metaverse are going to be increasingly important. So we have standards, we have ways to move forward and build a safe, sustainable, beneficial environment for all. So with that, I don't think we have too much time for questions, maybe like one or two, but we do have the Birds of a Feather talk tomorrow as well. We'd love to see you all here, all there tomorrow. But thank you very much for being here today. Yeah, is anybody? Sure.
Hi, do you envision AI actually having some kind of cognitive abilities in the future?
Yeah, so that's a really interesting question. The question that I often follow that up with is where do you define cognitive abilities, right? We have models today that you can give it a prompt and it'll answer your questions. It'll behave in a way that, man, this really feels like it's somebody talking to me. I think we're pretty far out from generalized AI, if that's what you mean by if that's the definition you take from like cognitive abilities. But I do think it's important to ask also, how well does mimicking something solve the problem that you're trying to. So if something appears to be cognitive, is it cognitive? Is it when do we attribute like a consciousness to an AI? That's a problem that, and a question that a lot of people are posing. I think in the future we will get there. We will kind of pass the Turing test with AI, but when we actually say something is conscious versus not conscious or something like that is often a subjective, personal feeling in a lot of ways. We don't have a good definition for that now.
And just to go off of that, with the advent of multitask neural nets, which is something that the Beyond ML project is working on, we have seen the ability to perform narrow tasks in a broader sense. So being able to train a model to perform natural language processing tasks, but also computer vision tasks. So combining those modalities gives it extra context, and that extra context can increase sort of a deterministic consciousness, if you will. But in terms of the cognitive abilities, there's been a lot of discussion about whether or not an AGI will need to have programmed in it some form of understanding of the human condition, however that would be defined, so that the decisions that are made by that AI can be more trusted as being oriented towards goals and things that we would value, if that makes sense. Any other questions? All right.
Thank you all.